right, so we're going to start by reviewing a few things that we know about right triangles, and then we'll talk about trig ratios. So I've got a right triangle that I've drawn over here, and we're going to start by figuring out which one of these sides is the hypotenuse. So can you tell me which side's the hypotenuse?
The 5.
The 5. So hypotenuse is always the longest side, and it's always opposite your right angle. It's always across from the right angle. Okay, so a hypotenuse is the easy one to identify. If you've done Pythagorean theorem in the past, you know which one that is. Everything else is relative to which angle you're looking at. So in this picture, there's an angle that's marked X and an angle that's marked Y. So if I'm looking at angle X, the side that is opposite X is the one that's across from it, so that would be 3. So opposite means across from. So if you're sitting opposite someone at a table, you're sitting across from them at the table. It's the same thing here. And then the side that is opposite Y, if Y is over here,
4.
would be 4 because that's across from the Y. 4 and Y are across from each other. Adjacent is the leg of the right triangle that helps make the angle but is not the hypotenuse.
So that would be 4.
So for X, that would be 4. So angle X is made by the hypotenuse 5 and this side 4. So that's 4. Adjacent in just normal language means next to. So it's the leg that is next to the angle that makes the angle, but it's not the hypotenuse.
So the only time you would write down the hypotenuse is for hypotenuse.
Yep, hypotenuse doesn't change regardless of which angle we're talking about. It's the hypotenuse for all, but opposite and adjacent change. So if I have Y, which side would be adjacent to Y?
3.
The 3. Good job. Okay, so if we come down to the next piece, I have another picture, and I've got A and B marked as my angles. 5 and 12 are the legs. 13 is the hypotenuse, so that one's easy. So if I'm looking at angle A, what side is opposite angle A?
12.
12, good. And then over here, if I have angle B, what side's opposite B? 5. Try to wait for me to ask that question. I know, just makes me feel like I'm doing my job. And then what side would be adjacent to A?
5.
5, because there's 2 sides that make up A, but 13's already taken because that's the hypotenuse, so it's the other one. I also think of it as the side I haven't used yet. And then for adjacent,
But we used 5.
we have, but not for angle A. So we did opposite of A, and then we're doing adjacent for A. So adjacent for B would be which side? 12. So it's interesting to see that the opposite for A is the adjacent for B. The opposite for B is the adjacent for A. So you do use both of them twice, but only once per angle. Okay, so we are going to look at some trig ratios in the foldy over here, but you have a little bit of space underneath this for us to write down some facts. So we're starting a unit on trig, and so the trig that we're going to be looking at, the trig ratios, I should say, that we're looking at only work for right triangles. I'm just going to use the triangle symbol. So they only work for right triangles. So that's something that you need to know. And then sometimes when they draw a right triangle, they're going to use a symbol that we haven't really looked at much. So I'm going to draw a right triangle really quick, just like this. So here's my right angle. And they might use this thing that looks like a 0 with a line across from it to represent an angle if there's only one angle marked other than the right angle. And that is the Greek letter theta. This is how they spell it if they write it out. So it just looks like a 0 with a horizontal line through it. It's the Greek letter theta. You're going to see that a little bit today, so I just wanted you to know what that is. Okay? So trig ratios, what we're going to look at today, only works for right triangles. If it's an acute triangle or an obtuse triangle, it doesn't work. But basically, it's based on the idea of similar triangles. So we've did a lot of work in past classes on similar triangles and setting up proportions where you just resize it, and this triangle is twice as big. Can we find the missing side and all of that? Well, someone along the way figured out that there is certain proportions that go in right triangles for certain angles, and that we can use it to find things that are missing. Okay? So let's take a look at some trig ratios. So this is how the trig ratios are written out the long full name. Sine, cosine, and tangent are the three main ones that you use a lot. When you get into science and physics, these are the three you're going to use pretty much all the time. And there are certain each one is a certain ratio from your right triangle. Sine is always the opposite side over the hypotenuse. So I'm going to abbreviate opposite, OPP, hypotenuse, HYP.
Yeah,
so we're not writing ours. Ours was already typed in there.
It shouldn't be.
Yeah.
Okay, hang on.
Yeah,
Okay, so just watch then.
all right.
Sometimes they call that O over H. It's weird because mine's not. So cosine is the adjacent side over the hypotenuse. And so I abbreviate that. Sometimes they call it A over H. And then tangent is opposite over adjacent, or O over H. And we'll look at a mnemonic device in a second. And so here's our...
A.
Or over, yeah, it should be opposite over adjacent, so that should be an A. Thank you. I did do that wrong. Gotta watch me. And so with this triangle, we can find the opposite and adjacent and hypotenuse for angle theta. And then we can come up with the sine, cosine, and tangent ratios. So when they started using calculators for certain things, which won't do this first lesson, but we'll use them next week, they decided to shorten sine, cosine, and tangent down to sin, cos, and tan. We still call them sine, cosine, and tangent. This is just what would fit on a calculator button, so they shortened it down.
I always saw those on calculators, but I never knew what they meant.
Yeah, you're going to find out this week. I know, it's exciting. Except the buttons won't do what we're doing today, but we're going to use them when we're doing stuff later. So just hang on, you will get to use those calculator buttons. So let's mark the triangle first. Here's our angle theta that they gave us. I always start by marking the hypotenuse. Which side is the hypotenuse?
3.
5. So 5 is always the longest side. I'll just put an H there for hypotenuse. So the longest side, it's opposite the right angle. That's always hypotenuse. And then I think opposite is the next easiest. So what is opposite angle theta? 3. So I'm going to put an O over there for opposite. And then the one that's left, when I said the one that's left is adjacent, that would be this one, which is A. Okay? So if I did happen to give you notes that are filled in, make sure that you're looking at this, because I don't know if I wrote everything in.
It's like,
If I did, that's fine, but make sure you're looking at your paper. Make sure you're looking at your paper and paying attention. Okay, so when we do sine of theta, sine is opposite over hypotenuse, so you go to your triangle. Opposite is 3, hypotenuse is 5, and you make a fraction. Okay, so when we do ratios, traditionally we use fractions. And then if we need a decimal, we can convert that later. For cosine, we want adjacent over hypotenuse, so the adjacent we said was 4. Over the hypotenuse would be 5. And then tangent is opposite over adjacent, so that would be 3 over 4. So basically, the trig ratios are a fraction for each.
So,
And it doesn't matter how big or how big we make this, whatever this angle is, if I make it bigger or smaller, the fractions would reduce to 3/5, 4/5, and 3/4. So if I upsized this and doubled all of them and made it 8, 10, and 6, your sine, cosine, and tangent, because the angle would still be the same, would still come out with the same ratios. So this is tied into the similar triangles we've done in the past. So there's a mnemonic device to memorize these. It is SOHCAHTOA. So you basically, if you learn how to spell this, SOH is so, CAH is ka, TOA TOA, then you will know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, And there's a really funny video that we'll look at here in a little bit that helps you memorize that. So that's how you're going to memorize. Okay, so one more example of these simple things, and then we'll practice a little bit. So here is theta for this angle is up here. Let's go through the sides. Which side is the hypotenuse? 13. Which side is opposite? 5. And which side's adjacent? I forgot. You guys ended up with copies that have this, so you're going to look really smart. All right, so if we set up sine, it is opposite over hypotenuse. So I go over to my triangle, go, okay, 5 is opposite, so it's going to be 5. Hypotenuse is 13. And so there's my answer. For cosine, I need the adjacent side over hypotenuse. So I go to my triangle. Adjacent's 12. Hypotenuse is 13. And then for tangent, we have opposite over adjacent. That ends up being 5 over 12.
You editing?